Okay, so here we go. Second short video of the day, and it's a subject that's been with me since my A level days, which is quite ironic because I got back in touch with an old A level friend. Um, but anyway, um, E equals mc squared. It's an equation that I've been grappling with since my days at A level. Interestingly, I had a bit of a run-in with the head of physics at Sussex University um, about the equation. Um, E energy equals, in its simplest form, not going into the detailed form, in its simplest form, E equals mc squared is energy equals mass times c squared. Now, the whole c squared has confused the heck out of me for quite a long time. However, c squared is the speed of causality. Essentially, energy can interact with itself and it's absolutely fine. Energy doesn't have causality. However, energy, when it's translated into matter, has causality. And causality is when matter interacts with other matter, or energy interacts, lower order energy interacts with matter. So you need to introduce a causality scale, which is basically a quantum imperative. Now, why do I say it's a quantum imperative? And here goes the computer again. I do need a new computer. The quantum imperative, or the quantum weight, is something that is going to be picked up in the large video. But we need to understand that all matter can have a quantum component to it, and that quantum component can be translated to mass or energy. So if you take the three components of E equals mc squared, any physicist, any mathematician know you can rearrange the equation to make whatever of those three components a subject. So matter can be translated into quantum causality and energy. Energy is translated in mass and quantum causality. But what this essentially means is that there is a component of causality to any life, or indeed to any matter. All matter is going to have a causality rating. I'm going to call it causality rating. It's not the best term, but it's slightly better than quantum weight, because I'm going to use quantum weight when we come to dealing with life forms, but call it a causality rating at the moment. And then where an inanimate object that doesn't move is going to have an extremely low causality rating, whereas an inanimate object that moves really fast is going to have a really high, well, in the scheme of things, it's going to have a higher causality rating. Whereas if you then have a life form that's moving fast, it's going to have an even higher causality rating. So there's 3 points in the scale, and increasing the amount of mass also increases the causality rating of a component. So yes, as an object approaches the speed of light, its causality rating is going to, its mass is going to increase, but also the causality rating of the object is also going to increase. Now, this isn't, the causality rating doesn't plug directly into the E equals mc squared equation. However, it does tie in with matter itself. In the E equals mc squared, we have a straight correlation. C squared is always C squared. C squared is the causality rating of matter in space. We'll stick with that. However, it's going to be key to think that this whole C squared it works, it fits, but it's not going to be quite right. Now, this was the famous argument that I had with I can't remember his name. I won't embarrass him, or I won't embarrass myself by naming him. But I did have a rather interesting conversation with the head of physics at the University of Sussex. I don't think he's head of physics anymore, but he then advised me to learn physics for 16 years and then come back and have the conversation. Well, fun enough, it's been about 16 years, and I'm in a better, although I haven't studied physics full time, I have had an armchair passing. Now, my type of physics is not specialised. It's extremely armchair, and it's extremely broad. But it's that generalisation, that broad scope on things that I think allows for greater insight into where things potentially, although they fit, they're not quite right. And it's my background in computer science that it really does tell me that you can test, and you can test, and something can work, but it's not right. Okay, I'm fully aware of that. You can have a computer program that produces a correct result, but it doesn't do it in the right way. And testing will just prove that it gets the correct result, but it doesn't understand. It doesn't get to the result in the correct way. Now, this is where I think that C squared is. It's currently it works, it fits, it's right at the moment according to our understanding, but I think it's not quite there, and it's this. I think it's going to be becoming more extremely complicated, and the key thing is going to be the speed of causality, or the quantum weight, which will I'll go more into that in a further. Anyway, the idea that quantum weight, mass and quantum weight come into play is the simple idea that the faster you go, the more objects you can interact with, the more quantum probabilities occur, and all those quantum probabilities occur simultaneously. And it's only when, as we know about the quantum universe, when the position is defined, that all the others disappear. So all quantum variations occur at the same time, and then only when the position is defined due to an interaction with another object that is also defined do all the probabilities fall off, the extraneous probabilities fall off. So at any one moment in time, an object moving at a certain speed could be interacting in several different ways with other objects. However, when something confirms the position in the quantum universe, only one quantum event takes place. It's very complicated, and it's one of these things that when you're at slower speeds, you're going to have a lot less probabilities, but when you're moving at the higher speeds, you're going to have a lot more possibilities, and therefore you're going to have a higher quantum. You're going to have a higher rating, you're going to have a higher number, and you're going to have a higher. I think in science fiction they called it not parallel universes, but quantum quantum probabilities, or quantum universes. I think the old school science fiction way is that there are other universes out there where every action you don't decide, or everything happens, but in a different universe. Now, what we're actually saying is that they don't happen in a different universe. They happen in our universe, but only on the quantum level, and it's only things only define when a known quantity comes into contact, and therefore a known quantity comes into contact, and therefore the quantum universe has to realign its position, and therefore one outcome is chosen. And herein is why I believe time flies when you're having fun, and it crawls when you're not. Because simply put, when you're not having fun, there's not many people around. You're going to be doing something mundane, something boring, blah blah blah, and this is life. But when you're having fun, generally there's going to be lots of people around. You're going to be interacting. There's a lot more possibilities that could occur. A lot more quantum probabilities are occurring, but these things snap into focus, and one probability occurs. So you could be playing, a game of Halo on the computer. Hundreds, you're playing it with 15, 20, 30 people. Hundreds of probabilities, hundreds, thousands, millions of probabilities could occur. Every single person in that game increasing their quantum weight for that particular game. But the key defining thing of the game is the end of the game, at which point all those quantum probabilities need to snap, and only one for each person becomes the real thing. And all the people in that game sync together, so the programming defines the endpoint at which quantum probability snaps into position, and extraneous probabilities do not happen. And it's the same if you go to a party. The next time you're talking to all those people, all those ways that you can walk around the room, the amount of drinks that you can have, all these little things, it's increasing your weight, it's increasing your quantum probabilities, it's increasing your quantum rating, and it's waiting for that one key event to define you all the time. It's waiting for that one key event to define, and then all of a sudden your entire history from the point at which you start to the point at which you end snaps into place. But you've already gone through that event, which is why it feels like time has flown. So, and I think I'm going to need a little bit of clarification on that. What I'm essentially saying is that when time crawls, you're going to crawl with it. So you are actually going along at the same crawl as time. So there's no probabilities, there's no extraneous things happening, and there's nothing that can alter anything. So you're creeping along with time, almost a one-to-one rate, maybe slightly different. However, what will actually happen when you're at a party or you're a social event where lots of things are interacting with you and lots of things are potentially happening, you're going to crawl along, but all the possibilities and everything that can happen, all different orders, the different permutations, the different combinations of events are happening. They're all actually happening, and it's waiting for that one event that says, right, well, we need to work out what's actually happened now, and then all of a sudden, boom, time has flown for you because you remember this one rather than this one. So there was that. You have the slow crawl, and that's time ticking by. That's everything that could potentially happen. You've got hundreds and hundreds of possibilities. Do you have that sip of drink? Do you gulp it down? Do you speak to this person? Do you speak to that person? Do you insult this person? Do you suck up to that person, blah 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 blah. And then there's that one person that going, you need to go home, you need to do this, you need to answer the phone. All of a sudden, time has flown because the one key event that has caused the quantum probability to define itself. And as you know about quantum probability, as we know about the quantum universe, we can know the speed of something or the position of something, but we can't know both. So once you define a position, the speed is no longer. We don't know the speed. So all of a sudden, as soon as the position is defined, you're there, and you're in that one. All the other possibilities fall off. You lose your quantum rating drops, and your quantum weight also drops. This will also define why people, there is a certain amount of weight loss when people die, and it will be why, yeah. There's a lot more to this, but we'll leave it there for this one, and we'll go into it in another one. As always, this is based on science. However, this is my interpretation of things. I hold my hands up. I know I may be completely wrong. However, I don't believe so. However, if anyone ever does watch these videos, please feel free to try and convince me otherwise. I'm always open-minded, and I'm happy to be proven wrong if you can. Thank you.